The content of this video is written based on this article. You can access this website to read. The ESP32 is a range of chip microcontrollers developed by Espressif Systems. If you don't know what Espressif Systems is, Espressif Systems, Shanghai Company Limited is a publicly listed Chinese semiconductor company. It focuses on developing and selling wireless microcontroller unit communication chips and modules that are used in Internet of Things, IoT. Two of Espressif's most well-known semiconductor products are the ESP8266 and its successor, the ESP32. The main features of ESP32 include wireless connectivity, high-speed processing, low power consumption, extensive memory, and built-in security. The chip itself does not have an antenna. Therefore, it cannot connect to Bluetooth or Wi-Fi yet, and the chip itself also does not have high-speed processing, because this time it does not have a crystal oscillator. About extensive memory, this chip itself also does not have flash memory, which is used to contain our code. You need to add a flash memory later. Look at this table. We have 2 columns, feature and specification, and 5 rows, processor, wireless communication, memory, external flash memory, and security. About processor. Most ESP32s are powered by a dual-core 10-silica 32-bit LX6 processor that can run at a clock rate of 240 MHz and relies on RISC-V CPU model. Dual-core, that means the chip can process 2 tasks at the same time. The clock rate of 240 MHz. To have this rate, you need a crystal oscillator, which is about 40 MHz. About wireless communication. The ESP32 supports various wireless protocols, including Wi-Fi, Bluetooth, Bluetooth Low Energy, and Zigbee protocol. About memory. The ESP32 has 448 kilobytes of ROM, 520 kilobytes of SRAM, 8 kilobytes of RDC fast SRAM, 8 kilobytes of RDC slow SRAM, and 1 KB of eFuse. ROM is read-only memory. You won't customize anything here. SRAM, static random access memory. You need to note this spec when you buy chips, if your function in code needs a lot of variables at the same time. RDC fast SRAM and RDC slow SRAM. You need to research these specs when your project is related to saving energy. And eFuse, if you are afraid of someone trying to read your code, you should research this spec. About external flash memory. As I said above, the chip itself does not have any flash memory. But the ESP32 supports external flash memory of up to 16 megabytes. And the last one, about security. The ESP32 supports IEEE 802.11 cybersecurity algorithms, featuring WFA, WPA/WPA2, WAPI, secure boot, and flash encryption. About WAPI, which is related to China. Secure boot and flash encryption, which are related to eFuse I just mentioned. If you want to see what your chip type is, you can see it on Arduino IDE. This is an overall image. We have SoC, which means system on a chip. We have module. This one has many things that I think are enough for IoT projects. Finally, DevKit. Every developer has a different DevKit. But I think the common point is every DevKit has buttons, LEDs, USB input used for uploading code, and male pins or maybe female pins. While the ESP32 commonly refers to a microcontroller chip, developers and device manufacturers can use 3 formats when working with it: chip, module, and development board. Here's a brief ESP32 model comparison. ESP32 chips. An ESP32 chip is a small, integrated circuit that contains the microcontroller, wireless connectivity. About wireless connectivity is not yet because, as I said, it does not have an antenna. And other components necessary for the device's operation. It goes unshielded, meaning the developers have to solder it to the module. Chips work well for custom designs where space is limited, smartwatches, for example. With this small chip, you can put it in a little larger thing and add your custom antenna later to suit your product. ESP32 modules. An ESP32 module is a pre-manufactured, self-contained unit comprising the shielded ESP32 chip, along with other components like a voltage regulator, crystal oscillator, and antenna. It can be easily mounted in the MCU and is a straightforward method of adding wireless connectivity to IoT devices. Notably, ESP32 modules are FCC approved, so manufacturers don't need to worry about Wi-Fi shielding compliance. As I said above, module is enough for IoT projects. ESP32 development boards. An ESP32 development board is a complete hardware platform containing the ESP32 chip and other elements like USB interfaces, voltage regulators, antennas, and onboard sensors. If you are a DevKit producer, you can add whatever you want, like sensors, camera, for example. It's a perfect way to build your IoT device and test it quickly. When choosing the best ESP32 development board, consider key specs like GPIO and ADC pins, Wi-Fi antennas, LEDs, shielding, and flash memory. I think you just should consider one thing when you develop education projects is the number of GPIO and ADC pins. To avoid any misunderstanding, Wi-Fi antennas and flash memory are usually on modules, not on DevKit or DevBoard. The following table is about the differences between ESP32 chips, modules, and development boards. If you want to build something small, you should research how to develop products by using chips. If you want to build something that size is not the matter, you should choose module. I think you shouldn't rebuild module because I think developers need a common standard to learn and develop. Maybe all developers need their own dev kits for testing quickly. You can add a camera, a temperature sensor on the dev kit, whatever suits your demands.